So today we're going to look at section 5.4, which is our introduction to what we call complex numbers. So one of the things we've been talking about is the real numbers and how awesome they are. But one of the things we don't talk about that often but need to today is there's actually other numbers that we don't see that exist. We had to come up with these numbers in order to solve a basic idea, a basic problem. X squared plus 1 equals 0. And if you look at our box right here, you can see that all you do is, we've done this before, solve for x squared, move the 1 over by subtracting 1, and then take the square root. Then you get plus minus the square root of negative 1. But we've already talked about how, wait a minute, we can't do that. We always like, no, can't do that. Well, I'm going to tell you something. We can. Now we move out of our real realm into what we call the complex and imaginary realm. We'll start with the imaginary numbers, which are the square roots of negative numbers. The reason we create this idea is the following. Two numbers times itself always gives you a positive number. Two real numbers, I should say. Negative 1 times negative 1 is positive 1. 1 times 1 is positive 1. There is no thing that you can multiply by itself to give you a negative 1. So the purpose of this is we decided to make this imaginary unit so that we can solve this problem. Right? So the square root of negative 1 in the real number system doesn't exist, but we call it the imaginary number I. I we write as a lowercase I, don't use the capital, and that equals the square root of negative 1, which is right over here. Again, the purpose is the following. We want to be able to say, what do we multiply by itself to get to negative 1? All right? So when we're dealing with this, we're going to say whenever we see negative square roots, we're going to call it an imaginary unit. We'll always take out that square root of negative 1 and make it an I. Okay, so let's just take a look at a couple. So the first ones we have here are the square root of negative 36, negative 32, and so on and so forth. What we do is we take the square root of negative 1 out, and you're going to multiply what's left, which is the square root of 36, right? We're always going to call this I. And this you should know. Well, that's 6. We usually write it coefficient first. We call this 6i. So the square root of negative 36 is 6i. Looks like the square root of 36, which is 6, but we just put 9. 32, what can we break down 32 to? Is there any perfect squares in there? We're realizing nope, so we're going to have to say to ourselves, what does 32 break down to? And let's see, if we do 2 times 16, 4 times 7, 14, 21, 4 times 8 will work. Or how about 16 times 2? So this is really the square root of 32 times the square root of negative 1. We break up the negative. We'll call this I. And this we know how to take care of. I just said it was the square root of 16 times the square root of 2, which we know is just 4 times the square root of 2. And then we have this I. We always put the I in front. We never attach it in the radical. It looks weird if you don't want it to make it look like the square root of 2i. That's just wrong. Okay? So, square root of 8. Of negative 8, we know it as 2 radical 2. But now it's just 2i radical 2. Right? Again, take out the square root of 8. Square root of negative 1. That's I. And that's 2 radical 2. Put the I in front. And then we could even do fractions. Well, we know that the square root, if we do this, is the square root of 25 over 36. And then that's really just times the square root of negative 1, which we're going to call I. And we know the square root of this, which is 5 over 6. So 5 6i, or we might write it as 5i over 6. Right, so that's our basic imaginaries whenever we're just dealing with square roots of negative numbers. Your calculator can do it. If you're in A plus BI mode, it actually will take the square root. You got to move it to that. I don't recommend it, but it's there if you want to. It's kind of fun to play with. All right. One of the things, though, we're going to see is the I cycle. The I cycle is really cool. Now, I've got a lot of overcomplicated things here, but let's just talk about this. We've already established that I is the square root of negative 1, right? Well, that's just I. Well, if we look at I squared, isn't it the square root of negative 1 times the square root of negative 1? Well, wait a minute. The square root of negative 1 times the square root of negative 1. This is the purpose of it. I squared, well, it's anything times itself when the square root is itself, right? Like the square root of 2 times the square root of 2 is 2. Well, the square root of negative 1 times the square root of negative 1 is negative 1. That's the power. Alrighty? Now, let's take a look at the third one. Over here, we're going to see it as just, hey, isn't this I squared times I? Right? Yeah. What do we just call the square I squared? Well, that was just negative 1. So negative 1 times I is just negative I. Interesting. Well, I to the fourth isn't that I squared times I squared? Wasn't that negative 1 times negative 1? Wasn't that just 1 then? Which is very nice. Well, let's talk about I to the fifth. Wasn't that I to the fourth times I? But didn't we just say I to the fourth was 1? So that's just I. Well, guess what I to the sixth is? That's negative 1. I to the seventh is really negative I, which is the same as I to the third. I to the eighth is just I to the fourth, which is just 1. Right? And if you notice, it continues this pattern. I, negative 1, negative I, and 1. The way we can look at it is it's kind of like a clock. We start at I to the 0, which we should know anything to the 0 power is 1, right? We'll go to I to the first, which is just I to the second, which is negative 1, which we were just talking about. And then we go to I to the third, which we just said is negative I. But then what happens when we get to I to the fourth? Well, I to the fourth, if you looked, isn't that just 1 again? And then the pattern repeats. So what you got to do is you just got to divide by 4 and see the remainder. If your remainder is 1, you're just I. If your remainder is 2, it's negative 1. If your remainder is 3, if you divide by 4, it's negative I. And I to the, that doesn't have a remainder, it would just be 1. Okay? So it's all a nice little division thing. If I asked you that, hey, can you do I to the 24th? All you would say is you can divide by 4. 24 divided by 4, go to a long division. How many times they go in there? 6 times. Our remainder is 0. So it's really the same as I to the 0. And anything to the 0 power is 1. Right? That's all you got to do. 37, to find out what I to the 37 is, you divide by 4. That doesn't go in there evenly. 9 goes in there, that's 36. I'm left with 1, my remainder is 1. So I really have just I to the first, which we just said is just I. All right. See this 9? It's how many times it repeats the cycle. That's all it's saying. I to the 62nd. I don't want to keep repeating how many times 4, 8, 12, 16. So I just divide 62 by 4. I know 1 goes in it. 4, 2, 22. And that's going to be 4 times 5, which is 20. And I got a remainder of 2. So it's really I squared. Now this is where we have to know our I cycle, that I squared is negative 1. And then the last one, 87, you just divide by 4, you get 2. 2 times 4 is 8. 0 subtract, bring down a 7. 1 times 4, that's 3, that's your remainder. That's all I'm looking for, so it's I to the third, which we've established is negative I. Okay, so it's all a division problem. I don't want to count 21 times around the clock. I got better things to do. The Yanks and the Mets are on. So we're just going to do a little quick division. Now, if you are using a calculator, remember, it's not going to shoot out remainders. Remainders, you got to realize this is 1 out of 4, or 0.25. 2 out of 4 is 0.5. 3 out of 4 is 0.75. And no remainder is when it goes in evenly. So you can use your calculator if you want to. So let's make sure we can do operations. Remember, you need to get rid of the imaginary part first, aka you got to write the i's in before you do anything to start. The square root of negative 4, we know is just 2i, because it's 4 times I, or square root of 4 times square root of negative 1. And then this is the square root of 121, which we know is already 11. And since it's negative, it's an I. So this is 6i plus 11i, because these two things multiply to give me 6. And I have 17i. All right, continuing over here, the square root of negative 16 is just 4i minus, this is 2 times which we call here is 2i, because the square root of 4 is 2, and because it's negative, it's I. 4i minus 4i is 0, which is interesting. Two things that were imaginary subtracted back to nothing. So imaginary things can disappear, like imaginary friends. All right. If the radical can't be simplified, then you simplify the remaining factor of the I out, leave it in simplest radical term. Remember, you can only add radicals that have like radicands. All right. So let's do these problems. Square root of 18, well, that's 9 times 2. And then there's the negative 1, right? So this is really 3, 4 times, this will become I times 3, and then I get a square root of 2, right? So that's really just 12I radical 2. Now, in order for me to add, I need an I and a radical 2, which, what do you know, it happens to be the square root of 50, negative 50, is just, look at that, 2 times 25 and negative 1. Square root of negative 1 is I, square root of 25 is 5, and I still got the 2. Right? And look, same radicals, same i's, add just the coefficients. 5 and 12 give me 17i radical 2. So I'm running out of time here, and I'll continue with another video, but you can see adding and simplifying complex numbers isn't that bad. It's radicals and like terms. Remember, take out the i's first, and that's not a violent thing. You just gotta get the i's in there. Okay, I'll talk to you guys later. Bye.